Hello, everyone. I'm Alex Arnaldi. I'm a solutions architect for SUSE. I work on the integrated solutions team where we integrate SUSE solutions, including our Rancher portfolio of products and our new acquisition of NewVector with our partners' products so that they can go to market with that improved solution. Today, we want to present to you one of our newest offerings. This gives us the ability to manage the Kubernetes node operating system in the same way that we manage the Kubernetes applications. So we're going to use Rancher to manage the onboarding and operating system upgrades of the Kubernetes nodes, which has the advantage of letting us consolidate all of the operations under one set of tools and one portfolio. In order to get this functionality, we have included a few new services inside of Rancher. One is the machine registration service. This is a service that's going to continually listen for new Kubernetes nodes that are coming online. Those nodes are going to identify themselves with their own TPM 2.0 hash. That gives us the ability to ensure that the nodes are registering the correct Rancher server and that malicious nodes will not be able to register. In order to create this functionality, we've created an entirely new generation of SUSE Linux, which is based on a OCI compliant container image that includes the bootloader, the kernel, and all of the user land processes need to run this capability. We've also enhanced how we create Kubernetes clusters inside Rancher Manager. Now we have the ability to define a Kubernetes cluster plus the workload that will be running on it, regardless of whether or not the nodes that are going to run that workload are actually on site and ready for action. That gives us the ability to launch applications en masse across many different edge locations. Those edge locations that do have nodes ready to perform the service will go ahead and create their cluster and start their workload automatically. And for other locations that are not fully configured yet, they will start their workload as soon as those Kubernetes nodes arrive and come online. We also have the ability to define clusters and applications based on specific node characteristics. So we may want to start at the node location to create the cluster in cases where that node has specific capabilities like GPU or NVMe. And we can also define clusters based on the node geography. So for instance, if I were deploying this in a hospital, I would want to run certain applications in a patient's room versus other applications in the hospital pharmacy. And I would want to make sure that I am sending those applications to the correct geography and not getting those confused. Once I've created those Kubernetes clusters, now the lifecycle management for all Kubernetes clusters inside Rancher is the same here as well. Now, one of the most key elements of this is going to be the ability to manage the node operating systems in terms of an OCI compliant container image. That means that the node operating system image and the container workload images can be driven through the same exact process of build, test, secure, and validate. So we don't need external processes to install the operating systems or to upgrade them. And once we have that upgrade available, Rancher is going to roll out that upgrade much in the same way that Kubernetes would roll out a new container image in a Kubernetes deployment. The process of bringing a new Kubernetes node on board is very straightforward. This is all going to be based on a golden image a golden master in onboarding image. With that image, we're going to simply bootstrap the edge node. It's going to go through a specific process of installation and identifying itself to Rancher server and adding itself to the inventory. Again, this is going to be done with the node's unique TPM hash, so that guarantees that once it reaches its destination at the edge location, we can specifically identify that node individually. After the node has been onboarded, it will be shipped out to its edge location. Once it's powered on and comes onto the network, it'll reach back out to Rancher server to complete the discovery process. At that point, now this node is a free resource in the machine inventory in Rancher, and it can be used to deploy a Kubernetes cluster. And again, we can start with the node if it has unique characteristics like hardware or geography, or we can actually just create new Kubernetes clusters from any group of nodes that happens to be at the right edge location. After the Kubernetes cluster has been created, we will automatically schedule the appropriate applications to it. But the real star of the show here is the ability to upgrade the operating systems on the Kubernetes nodes using the same infrastructure that we use to manage our Kubernetes application workloads. So we're going to use Rancher server along with a system update controller that we've created for the downstream node. And the process is going to look something like this. Here we're going to create a new updated operating system image. Again, and this is an OCI compliant container image. We can pull it in directly from the SUSE public registry and use it like that, or we can, again, drive it through the same build process we use for our application container images. We can add software, remove software, add security fixes, and whatever else we need. And once that container image is available to Rancher, we can identify which target clusters need to receive that updated node operating system image. At that point, Rancher server is going to take over and do everything else automatically. It's going to deploy the container image down to the individual nodes. It's going to write those to a passive partition, and we'll get to see a little bit more about the active and passive partitioning scheme when we get to the demo. And then it's going to schedule the first node to reboot into that new updated image. Once that node is back online, Rancher will continue on and schedule the next node to reboot so that no more than one node is offline at any one point in time. So thank you for your attention on this. If you have any questions, please email us, edge@suse.com. And with that, we'll move on to our demo. This demo is going to be of my imaginary company that owns two futuristic arcades, one located in Tokyo and one located in Toronto. These video arcades are interesting because the video game cabinets are simply a cabinet that contains a monitor and controls, whereas the compute element of these cabinets is going to be a small edge node that gets installed in the back. This allows me to repair compute failures very quickly and keep my video games online. And it allows me to change which video games are available on the floor at any one point in time. So since my locations are very far away from each other, I have to make sure that I keep logistics as simple as possible. So in this case, all of my edge nodes are absolutely identical. I'm going to have the new nodes manufactured at my ODM or original device manufacturer. And they're going to go ahead and go through the onboarding process there as well. Once those nodes are ready, they can be shipped out to whichever video arcade happens to need a new node at that time. Once the node arrives, my on-site team is going to install the edge node into the video game cabinet, and then they'll use a very simple application on their telephone to take a picture of the QR code on the back of the edge node, which represents the serial number, and the QR code on the video game cabinet, which represents the location in that video arcade in which it's been installed. They tap the submit button, and that kicks off an automated process which updates the inventory information inside Rancher. So I always have a searchable inventory information available right where I need it. Then they'll connect 3 cables and push the power button. Once the node is available, I will install a new Kubernetes cluster. We're going to use RKE2 here, which is SUSE's highly secure Kubernetes distribution. We used to keep it exclusively for the US government, but now we make it available to all of our customers. We're going to have some Calico security profiles automatically applied to all Kubernetes clusters that come online. And then we're going to apply the specific video game application automatically when the Kubernetes cluster is ready for that. So here we have the Rancher opening screen. If we click the hamburger menu here, We can see we have several global apps that Rancher can use to manage Kubernetes clusters and their applications. We're going to get to see these top three during this demonstration. So just very quickly, I'll point out this bottom one, virtualization management, is just the ability to manage, to actually run virtual machines on top of a Kubernetes cluster using KubeVirt and some of our specific storage technologies. If we come here to operating system management, this is the dashboard we use to manage the operating systems for the Kubernetes edge nodes. If I come here to machine inventory, I see I have 4 edge nodes that are already made themselves available to my Rancher server. The ones here that show unavailable are the ones that have done that initial registration process at the ODM, but have not yet been powered on at their edge location. I have one cluster here. That is a member of a, I have one edge node here, which is a member of a Kubernetes cluster. And if I look here at my desktop, we can see that for this demonstration, I'm using KVM virtual machines and virtual machine manager. Here are the 4 individual nodes that we see in the Rancher interface. To simulate manufacturing a new edge node, I'm simply going to clone my template. And now this edge node is being manufactured at my ODM. When it's ready, I will take it through the bootstrapping process. First thing I'm going to do is just a little bit of housekeeping for the sake of my demo. I'm going to grab the serial number of this unit. I'm going to add it to the name of the virtual machine, just so I can associate the two between the virtual machine manager interface and the Rancher interface. To provision this node, I have 3 options. I can plug in a bootable USB drive. I can attach an ISO, which is what I'm going to do here. Or I could PXE boot this image onto this node. Then I simply press the power button and the provisioning begins. Now I'm showing the console of this unit just so we can watch the install happen, just so I can make for a very exciting demonstration here. But what I want to emphasize here is that this is a 100% hands-off provisioning. So there's no monitor or keyboard required for this. As this unit boots up, it's going to come up on the network, and it's going to register itself with Rancher server in this machine inventory. So I see I have 4, and actually that just happened. So after it's registered itself, it's going to partition the drive, and then it's going to write that OCI compliant image down to the hard drive. Once it's completed all of these processes, it's going to power off, which is my signal that it has become ready to ship out to my edge locations. And we can see that the serial number BAE6 is right here, and it has done that initial registration with Rancher server. And now my unit is fully provisioned and ready to ship off to my edge locations. The only thing I'm going to do here is remove the USB drive or the ISO image. And obviously, if I was doing PXE boot, that would not be required. So now I have shipped this off to one of my video arcades, and my on-site team has positioned it into the back of a video game cabinet. They have used their phone app to update the machine inventory information, attach 3 power cables, and press the power button. So that is the that's the only technological skills that are required to bring this node online, eventually make it into a Kubernetes cluster and run a Kubernetes application on it. Now here I want to actually just stop the boot. And this is not required. I just wanted to kind of show you that partitioning screen that we saw earlier. Here we see the active partition that it's going to boot into. When it comes time to upgrade the operating system, that will get written into the passive partition here, and then that partition will be made active, and then we'll just reboot into that one. In addition, we have a very simple recovery partition that simply brings the node onto the network so that we can troubleshoot if it's having issues. But we'll continue with the boot of this partition, and I can go ahead and just close this out. So now this node has come back in to finish the discovery process. I can click on it and get some more information. And we can see that I can associate the serial number that's on the back of the node with the actual location. I see that this particular unit arrived at my Toronto video arcade, and it is installed in the game cabinet located H11A. Now I can create a Kubernetes cluster based on this node. That one might be very specific, where I would want to do it based on hardware. In this case, geographic location would probably also make sense. But I do want to demo something else for you here. I want to create a Kubernetes cluster from based on the application itself. So I'm going to click Create here. And for anybody who's not familiar with Rancher Server, this is a standard interface we have for which we can create hosted Kubernetes clusters. We can create Kubernetes clusters on different kinds of virtualization and cloud platforms. And then one thing I want to point out here is that Rancher Server is completely API driven, which means I can use the point and click method if I want. That's not very scalable. Better off, I can just go ahead and connect directly with the API server, send in all the commands I want. And the nice thing is the command set to create an EKS cluster is extremely similar to an AKS cluster and a GKE cluster. So I really don't have to learn all of the ins and outs of every single one of these platforms to be able to have the power to deploy clusters on them. And that includes these down here. In this case, we are going to create an elemental cluster. I'm going to call this cluster game cluster Pac-Man. And in this inventory selector template, I'm basically creating rules to narrow down on which individual nodes in the inventory I want to deploy on. So I have two different arcades in my inventory, and I really want to work on that Toronto one. So I'm going to go ahead and add a rule that says arcade location is Toronto. So now I have three machines inside my inventory that could be selected from that. If my geographic location is sufficient at just somewhere on the game floor of my Toronto arcade, I can go ahead and just create my cluster here. If I want to get even more specific, I can add additional rules, and I can do something like game cabinet floor coordinates and this exact location. And now I've narrowed it down to just one specific machine inventory that fits that need. So the point being, I can create whatever scope I want to deploy that application. If it just needs to be somewhere in a certain location, I keep that scope quite wide, and then I have a lot of flexibility. If I really need to narrow down, I have that capability as well. We see here we're going to create the RKE2 cluster. This is the Kubernetes version we're going to use. For container networking, SUSE supports all of these that we see here. Of course, here we're going to use the Calico CNI because we need the extra security features that it offers. And as I mentioned before, as soon as this Kubernetes cluster has been deployed, we're going to immediately deploy some Calico security profiles to it to improve security. I'm also going to add a label here, and this is going to be game is Pac-Man, and we'll get to see what that does in a few seconds as well. Now it's simply a matter of creating this Kubernetes cluster. Now this process usually takes about 4 minutes to create the cluster and another couple of minutes to deploy the application. So we're going to go ahead and just move on, showing off this cluster here that I've already created. We're going to move on to our continuous delivery portion of Rancher. If you know Argo CD, this is extremely similar. It's simply going to be a GitOps continuous delivery engine. It can be used with a CI/CD pipeline, or it can actually just be used independently, like I'm doing here. So what we have here are certain security settings, effectively, that I'm going to apply to the Calico software that's already installed on my Kubernetes cluster. This standard profile is something that I have set up to deploy to every single Kubernetes cluster that Rancher manages, whether they're edge, cloud, or data center. This medium profile is something I can apply to individual clusters if they need a higher security profile, or I can actually apply these to entire areas, regions, whatever granularity I need to raise the security profile of those particular clusters. Here I have a storage class that I'm going to apply to ArcAE2. ArcAE2 doesn't come with a default storage class, and so I can apply that as needed. I'm just going to use specific rules to target, in this case, as before, all clusters, only clusters that need it, or a specific group of clusters. Below that, I have all of my application software that I'm going to deploy based on various needs. So here I have, up here is going to be a video game controller that this particular video game needs. So there's a dependency between this software and this software. And the video game controller has a dependency on its CRDs being created ahead of time. So there's a dependency between these two as well. So very easily, I identified that this video game needs this software to be ready before it can be deployed. This software needs this software to be deployed before it can be deployed. Very simple to establish there. Now, what's interesting here is that Pac-Man is actually a standalone application. So I've created the rule set that says, if it's Pac-Man, don't bother with any of these. I don't need them for this particular application. And with that, we're going to come back over to that cluster that we identified here. I am going to copy the kubeconfig file for this particular cluster to the clipboard. I'm going to come over here to a window on my Windows laptop, a terminal, I should say, on my Windows laptop. Okay, and here I have the kubeconfig file for that. The one thing I want to point out here is that in order to access this Kubernetes cluster, I'm going to go through my Rancher server. So this exact same Rancher server that we see up here, which means I'm going to be subject to all the role-based access control that I've created centrally inside of Rancher. And it means I am going to, I may have certain profiles that allow me to see only the Tokyo video arcade or only the Toronto video arcade. But I can apply those role-based access control rules uniformly across all of my landscape, cloud, edge, on-premise, whether it's 2 locations or 2,000. Okay, and with that, I'm just going to do this. Okay. With that, and now I'm just doing a simple port forward to that service that I have running in that particular Kubernetes cluster. Okay. And now if I just open this up here and my demo goes well, we will see Pac-Man. So that's the end of my demonstration because I am going to play Pac-Man. If you have any questions at all, please feel free to reach out. Give us an email at edge.suse.com, and I appreciate your time.
Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the scan results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure and does not have any misconfigurations. Calico helps you continuously assess your Kubernetes configuration using compliance reports that assess your configuration against CIS benchmarks. I scheduled my CIS benchmark report to run every 24 hours. The number of nodes passing or failing the CIS benchmark tests is color-coded. And here are the top failed tests. I can also download the full report to get more insight on each test and how to mitigate its risk. At this stage, I have scanned all my images, allowed the deployment of only those that pass the security requirements, and I have also assessed my deployment environment against CIS benchmarks. Try it yourself by signing up at www.calicocloud.io. Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the scan results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application